Now we're going to begin 1.3 complex numbers. Simplify this expression. Okay, so we need to, I'm going to show you a little method here that always works. We're going to take this 18, we're going to factor it completely. Now there's a few ways to do this. You can make a tree, or you can, this way always works. You just start dividing by what you can. So it's divisible by 2 because it's even. 9 is 3 times 3. This is 2 times 3 times 3. And what we're going to do here is we're going to make 2 boxes. You'll see why it's 2 in a little bit. And then a little jail or holding cell for those that don't behave. So here, actually right away, the rule here is that only pairs can go in here. So if you have a number that for each of these, then you can put it here. The 2, actually we don't have enough of, so it stays here. The 3s, there's enough to go around. And what's nice is that this becomes your answer. 3 radical 2. We'll do some more so that will make more sense. 3 radical 2. All right. Right. As a power. So the rule here is that i's have a repeating pattern. So if you think about it, I is the square root of negative 1. I squared, which we just write as I squared is negative 1. I cubed is I squared times I, which is just negative 1 times I to the 4th is I squared times I squared, which is negative 1 times negative 1 is 1. And then once you get to this point, it just repeats itself, because I to the 5th is going to be I to the 4th times I, which is just, 1 times I. So you can see how it repeats over and over again. So the rule here is basically take your remainder after you divide by 4. So for example here, 5 would be, 1, remainder 1. So you just take that 1, you look up here so that this is like a 1, right? And it would just be that answer. So here we apply our rules. So first of all, now we can convert this right away, but we're actually going to use our rules of division. When we divide exponents like this, we subtract whatever's on the bottom. So this is going to become I to the 11th. Now we use this rule. 11 divided by 4 is 2. The remainder is 3, so it's going to be negative I. Because we're basically going to have I to the 11th is I to the 4th times I to the 4th times I cubed. This is, 4 plus 4 is 8 plus 3 is 11. This is 1, 1, and we're just left with the I to the 3, so this is negative I. And be sure you use their I. So as you can see also, the reason I'm doing this is because I haven't seen these problems before. They're randomized, so I haven't worked them out in advance. So here we want to add the complex numbers. Now the rule here is basically, you know, you add like terms. So there's this is the real term right here, and the b is the imaginary term. Imaginary. So this is a is real, b is imaginary. So here, these are the real parts. So we can add them just like this: radical 5 plus 3 radical 5. And then this minus 3i. We can just put it on top of each other. Plus 3i. So I just rewrote it vertically. There's like an imaginary like 1 right here, if you will. So you can add these together. This becomes 4 radical 5. And then here, this just goes away. So 4 radical 5 is the answer. You know, technically it's 0i, but we can just write, you don't have to write that part. Well, we'll find out. That's 4 radical 5. Because this way is a lot simpler. Oops. A radical 5. Multiply. So it always wants the simplest answer. 0i, of course, writing just 0 is simpler, or writing nothing is actually simpler. So write this in the form, so basically just multiply this out. Now, it's anytime, even when we don't have imaginary numbers, it's very tempting for the student to just say, oh, I'm just going to square the first and square the second. That's not how you do it. What you want to do is you want to write it twice so that you're not tempted to do that. Okay. So now we just FOIL. So this is going to become first. Now radical 7 times radical 7. There's 2 ways you can do this. You can think of this as, well, the radicals are going to cancel out, and I'm left with 7. Or you can multiply what's inside. 7 times 7 is 49, and then the radical of 49 is 7. Either way, you'll get 7. I like to think of it as the radicals cancel out. It's a little easier. Here we have minus 3i radical 7. And once again, minus 3i radical 7. And then minus plus 9i squared. Now what's I squared? Negative 1, right? So this is just going to become minus 9. And then here we're going to combine like terms. 7 minus 9 is minus 2. And then here we have minus 6i radical 7. Now here we're going to find out if MyMathLab likes 6i radical 7 or if it wants 6 radical 7i, because it wants this form. So we'll see. I guess we'll write it this way so that we can't complain at us later. So we have minus 2 minus 6 radical 7. Now it's very important, if you're going to do it this way, make sure you get out of the radical. See how I was inside of it? Now I just press the right arrow to get out. Now I'm out of it, and that should be good. And our last one is divide. Now when it comes to complex numbers, you can remember this is like a square root of negative 1, right? So we never want square roots or any radicals in the bottom, so we have to rationalize. Well, this is our analogy, denominator. And how did we do that before? We would multiply by conjugate. Now in this case, what that means is that 2 minus I becomes, you just change the sign, 2 plus I, okay? So we have 2 minus I, and to be safe, I'm going to put parentheses when there's more than 1. And we're going to multiply this by 2 plus I, 2 plus I, okay? This is 1, so this doesn't change the value because I'm just basically multiplying by 1. So this becomes 4 plus 2i. Now here's a secret about, if you think about this is like a plus b, a minus b, or vice versa. This is the difference of squares. That's why this formula becomes so nice. So I don't even have to FOIL this out. I can just square 2 times 2 is 4 minus b squared. So I already have a minus. So this minus and this minus are going to make it a plus. So plus, now you can think of it as there's like a 1 right here, right? So 1 times 1 is 1. Now this right here is 5, right? Now remember, we have to write it in the form a plus bi. So you might write it like this, but I think my math lab will complain that that's the wrong answer. So what it wants is it wants a, the real part, plus the imaginary part, like that. So 4/5 plus 2/5 I. And there we have it. Now we're done with 1.3.